All right, so let's talk about colligative properties of solutions. And colligative properties are a collection of physical properties of a solution that are affected by the number of solute particles. So the properties of solutions are going to be different from the properties of the actual solvent by itself. And the four things that are going to be affected by this. One's going to be vapor pressure, and the actual vapor pressure of the solution versus the solvent will lower. Another one is boiling point, and the boiling point of the solution will be higher than the boiling point of the solvent alone. The freezing point of a solution will be lower than the actual solvent by itself, and the osmotic pressure is going to increase compared to its solvent by itself. And this will all depend on the molality of the solution. And molality is moles of solute over kilograms of solvent. And don't forget the density of water is 1 gram per milliliter. So we can just change the number of liters to kilograms. They should be the same conversion because the density of water is 1. And don't forget that the unit for that the symbol for molality is a small m. So this will depend. This molality is what's going to show how much all of these guys are affected. So let's talk about different types of things that should be in solution. So you have electrolytes, and as you should remember, electrolytes are things that conduct electricity in solution, or ionic compounds. And ionic compounds, as you know, will break up in solution. So for example, we have sodium chloride. When you put sodium chloride in water, it'll actually break up into a sodium ion and a chloride ion. So if you put 1 molal of sodium chloride in solution, you'll actually get 2 molals of particles in your solution. So it'll actually break up. So you have to know that your solute is going to be an electrolyte. Also, if it's an electrolyte that has like calcium chloride that has more than just 2 particles, this will break up into actually 3 particles for every one. So if you have 1 molal of calcium chloride, you're actually going to get 3 molal of particles, which will affect this more than sodium chloride will affect it, even if it were the same amount. Also, non-electrolytes do not break up in solution. So however amount you put in solution is the amount that is the amount of particles that will actually be in the solution. So for example, here's table sugar, which we know is a molecular compound. If we put 1 molal of a non-electrolyte, it'll just be the same. These are not going to break up into its atoms. So it'll stick together. It'll break up from each other, but it'll stick together in terms of a compound. So if you have 1 molal of a non-electrolyte, you're going to end up with 1 molal of particles of a non-electrolyte. So this is actually going to play a big part in dealing with the colligative properties of solutions, boiling point, freezing point, and vapor pressure and osmotic pressure. And we'll talk about those in each separate videos.